Okay. Shh. Foundations of chemistry. Okay. Yes. Okay. Let's be quiet, please. Quiet down. Okay. So, chemistry and matter. So, first of all, got to get a definition to it. Chemistry is just the organized study of the composition and interactions of matter. Okay? Ladies, ladies, quiet. There's 5 branches of chemistry. Organic chemistry, inorganic, physical chemistry, biochemistry, chemistry, and analytical chemistry. Okay, stay up. Chemistry. We're going to be talking about it. We're not doing labs this year. Yeah.
If we blow up the school, Mr. Brown, it's just another loss.
Yeah.
And you love mustard jack.
Yeah.
What's up with you and mustard jack?
Okay, are we done with number 2?
No.
Shh. Quiet down.
Biochemistry, chemistry. That's my favorite type of chemistry right there, too.
Chemists. I'm going to make the change before you say something. Okay, chemists, science. Shh. Hey, enough talking on the sidelines. Chemists, the scientists who study chemistry, study 2 things about chemistry when they're dealing with it. 1, the physical and chemical properties of matter, and the role of energy in those chemical changes or in chemical changes. So when they're looking at things, these 2 things is what they're primarily looking at, but then they branch off from there in a lot of ways. Okay? Physical and chemical properties of matter and the role of energy in the chemical changes. Okay? So let's take a couple steps back. Okay? Shh. Let's go back to the future. And let's study chemistry, history. Shh. Now, people have used practical chemistry since before the flood. Shh. By combining raw materials into useful substances. The Bible describes a man named Tubal-Cain as an instructor of every artificer in brass and iron. Shh. Artificers are just masters of invention. Okay, enough chatter, enough trying to talk over you. Checks are going down. I'm giving you enough verbals. Artificers use ingenuity and magic to unlock the extraordinary capabilities in objects. Okay? Scientific magic. To be an artificer, man needs that skill that requires a working knowledge of chemistry. So in order to do it, you've got to know at least something about chemistry. Now, chemistry is not an easy subject. It is a bear all by itself without anything else helping it along. Okay? But if you can get the foundations of it, you at least can grasp the ideas, and then hopefully those ideas will carry you through the process, okay? Now, ancient Roman engineers used concrete to construct giant buildings and aqueducts. Okay? They built them back then. But they had to know the chemistry of the materials in order what would work best. Throughout the centuries, apothecaries have produced perfume, ointments, medications by combining various chemicals, extracts, and herbs. They are chemists. The Japanese swordsmiths of the 1400s produced hardened steel swords through careful chemical processes. Okay? Number 6, the Reformation triggered the renewed curiosity about nature. Okay? So, number 7, by 1800, scientists had laid the groundwork for a revolution in the science of chemistry. Okay. Man sought to make chemical knowledge useful for good of mankind. Reformation. And as soon as one chemist, here's the trouble. As soon as one chemist made a discovery, ladies in the back, you just both got to check. As soon as one made a discovery, others applied the new knowledge to answer other questions. Okay? So it was a vibrant technology. It was a vibrant situation, a needed one. People were eager to learn. People were eager to have this and be able to apply it. Chemistry affects every aspect of our modern life because we use the products that chemical industry. Shampooing your hair, putting on cosmetics, brushing your teeth, okay, the toothpaste, wearing dyed clothing made from nylon or polyester, riding in a car, pitching a tent, using a camera, a computer, or a flashlight, taking medicine, reading a book. All those pages have been compiled with matter. Modern high-yield agriculture depends on chemistry to provide enough food for large urban populations. So see, there's a lot of areas, and this just touches the basis of them, okay? You're going to get your second here in a minute, ladies. So why is it important or impossible to draw a distinction between natural substances and chemical substances is that everything in nature is made of chemicals. Somehow, some way. So to draw a distinct point between nature and chemistry is that everything is involved in chemistry, or chemistry is involved with everything, chemicals. Okay? Ready? What? What's a chemical? Okay. No, that's a mixture. Okay. So, let's look at the composition of matter. We start off with the atomic theory of matter. It was presented by this gentleman, John Dalton. Okay. A British chemist. He proposed the atomic theory of matter. Okay, girls, you just got 2, and Adrian got 1. Now, Dalton was a Quaker by birth, grew up with a strong belief in the Bible. He attended a village school in Eaglesfield, England. At the age of 12, he taught at his school for 3 years. Okay. And you guys are what, 15? Okay. You take my position, take my job. For 12 years, he taught at another school. Okay. So for 3 years, then at age 15, he started at the second school for 12 years. So by the age 27, we're looking at. Yep, there it is. He moved to Manchester, England, where he spent the rest of his life teaching and researching. Here's his atomic theory of matter. This is what he came up with. Every element consists of tiny particles called atoms. Every element consists of tiny particles called atoms. Okay, second part of it. All atoms of a particular element have the same properties. So every element consists of those tiny atoms, or tiny particles called atoms. And those atoms all have the same particular element of the same property. Okay? The third part. Different elements have different properties because their atoms are different. So every element consists of tiny particles called atoms. All atoms of a particular element have the same properties. And then different elements have different properties because their atoms are different from everybody else, or for everything else. This is probably the most writing you've done for a while. Number 4. Atoms of different elements can combine in specific ways to form compounds. Okay? So you have every element consists of tiny particles called atoms. All of those little atoms of a particular element have the same properties. Different elements have different properties because their atoms are different. Okay? But then you can take the different elements or atoms and combine them together and you form a compound. Okay? Number 5. Chemical processes are the result of the rearrangement, the combination, or separation of those atoms. That is Dalton's atomic theory of matter. 5 steps. Everything is made of tiny particles called atoms. All the atoms of a particular element are all the same. They have the same properties. Elements, different elements have different properties. Okay? Because their atoms are different. And the atoms of those different elements can be brought together, combined to make a compound. And then the chemical processes that result are the rearrangement, the combination, or the separation of those atoms. Okay? That's his 5-step process to the atomic theory. Say, well, what's the general as your next letter C? Actually, I have it on mine as D. Are we at C?
We're at D.
So I forgot to change it to C. I forgot to change this to C. Okay. Letter D. The general breakdown of matter is this. 3 things. Atoms, those tiny particles that make up matter. Elements, the substances composed of single types of atoms. And then compounds, the substances composed of 2 or more elements bonded together. Okay? So, as the picture that you see on the screen right now, elements, okay, is the first one, letter A. Therefore, on your notes, letter E, 1E, elements are the building blocks of all substances in the universe. Okay? Even though atoms are the tiny particles that make up everything, the elements are the combination of those atoms. And so therefore, elements are the building blocks of all the substances. So, as of 2019, letter F, chemists have identified 118 elements. I should have put elements on the backside of that. They break down like this. 88 elements occur naturally in the earth, and 30 of them have been produced in the laboratory. Shh, girls. That was as of 2019, 2 years ago. And I'm sure that number probably will increase, okay, knowing our technology and so forth. You know what's coming with this, don't you?
Yeah. That table thing.
Okay, go back to page 1 of your notes. The very top of the page. There is a table on page, or table 13.2, page 308, 309. Okay, that has various elements on it. And I'll give you the list here. We'll go over that list here in just a little bit, but I want to introduce this. In lesson 133, right now we are on lesson 128. Okay? So probably the first part of next week or midweek next week, there will be a quiz over the bold elements from that chart. Okay? So make sure that you are studying those, and I'll give them to you here in a little bit. But that's where you can find them in case you don't have the chart or you don't have your notes with you at a time or something. Okay? But that's page 1 of your notes, the memorization of the bold elements on page or table 13.2, pages 308, 309. Now, the common aspects of elements. That's 1G. First of all, you have pure elements are uncommon in the earth, but are usually found combined into compounds or mixtures. Physical combinations of elements and mixtures, or compounds, elements and compounds. That's what a mixture is. Okay. They're also known, excuse me, they are also uncommon in every use. One H. Elements that are combined to make various material, such as alloys or metal mixtures and plastics. That's basically everything involved with the atomic theory of matter. Okay? Notice that in your little diagram here, alloys have different metals with different sized atoms. Different sizes of atoms disrupts the orderly layer of atoms, makes it more difficult for the layers to slide over each other. Thus, alloys are harder and stronger than your pure elements. Okay? Now, in this atomic composition of matter, guys, we have all of our elements, atomic symbols, or what's also called chemical symbols. These are just unique abbreviations given to each element. So for like this one, He stands for what? Do you know? What does He stand for? Anybody? Helium. Okay. So He is the atomic symbol for helium. And on the element periodic table of elements, you'll find the He. That would be your element of helium for that. Okay? Shh, quiet. Now, the benefit of the chemical symbols to scientists is this. It allows scientists who speak different languages to communicate concisely and unambiguously. You got 2, you want 3 girls? Girls, you've done nothing but talk back there. You want 3? I don't care. Universal identification. Okay, now, this is still up here. In your book, on page 307, there is a picture of various chemical symbols from the alchemists to the present. I tried to get that up here on the screen. I couldn't find what they had. But it is unique how they have shown that. But here is what you need to know. Okay? Is everybody up with me on these? On this slide? Okay. Number 3. Your elements and chemical symbols that you need to memorize. Off of that chart on pages 308 and 309. Uh, I don't have them on here. Numbers? I don't see any numbers. Oh, yeah, just put the symbol. Yeah. This is what your quiz is going to look like, or something like this. Okay? It may have them all. It may not have them all. I'm not going to tell you. But these are your general elements and chemical symbols that you generally will need to know as you go through chemistry. The ones that really stand out. Okay? Aluminum, Al. Argon, Ar. Arsenic, As. Barium, Ba. Boron, B, quiet. Calcium, Ca. Carbon is C. Chlorine, Cl. Copper, Cu. Gold, Au. Helium, He. Hydrogen, H. Iodine, I. Iron, Fe. Krypton, Kr. Lead, Pb. Magnesium, Mg. Mercury, Hg. Neon, Ne. Nickel, Ni. Nitrogen, N. Oxygen, O. Phosphorus, P. Potassium, K. Radium, Ra. Radon, Rn. Silicon, Si. Silver, Ag. Sodium, Na. Sulfur, S. Tin, Sn. Tungsten, W. Uranium, U. Zinc, Zn. And zirconium, Zr. Okay? That's your chart of symbols and elements that you need to be memorizing. Okay? And again, we are on lesson 128. That's in lesson 133 that quiz is. Okay? And it's coming up on Thursday. Yep. Because we're skipping a few lessons because of labs. So that quiz is on Thursday, ladies and gentlemen. Okay? Now, so tonight's homework is section review 13.1, reading pages 309 to 311. Okay? You have about 10 minutes left of class to be working on it. So, deals, I would say, normally I would say bye to you. So, I'm still going to say bye because you'll be reading this or looking at this later on. So, we'll see you tomorrow, DLs.